Python and database access. As your Python program grows, you may have need for persistent data storage. The way that most application frameworks work in this regard is to make use of an application programming interface, or API, to connect to one or more database systems. Therefore, in this nugget, I'm going to show you, first of all, the basics of connecting Python code to a relational database management system, or RDBMS. Specifically, we're going to focus in on the SQL Lite compact RDBMS that ships as part of the standard Python library. The good news is that what you learn here in this nugget regarding SQLite is directly transferable to whatever your chosen permanent database platform is, whether that's Microsoft SQL Server, Oracle, MySQL, etc. Let's get to work. Now, when we talk about connecting disparate systems, for instance, a Python script to a relational database management system, this involves talk of some kind of connector or translator or interface between those two systems. An API addresses this need. An API stands for Application Programming Interface, and we can draw an analogy to computer and programming APIs to human-computer interaction. Think of what happens when you sit down at your computer. You have interfaces for inputting data or sending data into the computer to be processed. You have your keyboard, you have your mouse, you may have a headset with a microphone. All of those represent interfaces to connect one entity, namely you, the human being, to a second entity, in this example, a computer system. So the trick when you're learning a programming language is to get hold of those rules, those specifications, those data structures, functions, routines, etc., that are published by your destination entity. So for instance, if we wanted to connect Python to Oracle, our job is to see if Oracle itself or some third party has published an API specification that enables us to pipe our Python into an Oracle database. Now, some standard database APIs that are out there in the world include the following. Perhaps the most popular is ODBC. This stands for Open Database Connectivity. In the Java world, we have the Java Database Connectivity Standard, that's JDBC. In the Microsoft .NET Framework world, there's the ActiveX Data Object, or ADO. Now, what's crucial for us as Python developers is that we need to understand that the API published by Python to support connectivity with relational database systems is called DB API version 2.0. Now, the good news is that there are lots and lots and lots of API providers. Therefore, you can quite easily hook in Python to any contemporary RDBMS. There's the MySQL for Python library, there's CX Oracle for Oracle, there's ADODB API for connectivity with Microsoft SQL Server, there's Pygre SQL for PostgreSQL, and the list just goes on and on. The thing to remember again is that as long as we're using a library that uses DB API, it's not only easy to get Python talking to a particular RDBMS, but it's also easy to go from one RDBMS to another. You might have a Python project that's currently interacting with MySQL, and then due to an architectural change, you now need to get that code talking to Oracle. The amount of code you'll have to redo using DB API is very small thanks to these API standards. In the Python wiki at wiki.python.org, there's an excellent article on database programming that I think you should read. It talks about relational databases, the DB API particularly. You can read FAQ lists on it. PEP 249 is the official specification document for the DB API. This page here, Database Interfaces, is particularly useful, I think. This goes in and allows us to take a look at specific database systems, DB2, Mozilla Firebird, IBM Informix, and so on. And what happens, you can click these, and the Python folks have been nice enough to give us pros and cons of connectivity between Python and that database system. And also they'll give you a list, a current list, of DB API 2.0 drivers or modules for each platform, and you definitely have some choice here. I'm just looking at MySQL, and I could download MySQL for Python, or I could download MXODBC, or I could download PyODBC. You see what I'm saying? So you'll absolutely want to do additional research to read the pros and cons of choosing a specific DB API library to connect to your chosen database. As I stated at the beginning of this nugget, we're going to look in this nugget at SQLite interaction with Python. SQLite is a tremendously powerful little library. It's actually less than half a megabyte in size. It's written in C. And what SQLite has going for it is that it's not a client-server system. That is to say, for instance, if we wanted to get a Python application writing to a database we create in MySQL, well, there it stands to reason that we have the MySQL daemon or server process running on our own or a remote box. That can become really cumbersome, especially when we're porting an application from one development environment to another. SQLite, on the other hand, is an ACID relational RDBMS. ACID is pretty much, to use the term recursively, the acid test for whether a relational database management system is truly standards compliant and in particular transaction safe. A stands for atomic, C stands for consistent, I stands for isolated, and D stands for durable. These are core elements of what a database transaction is. Now, of course, you'll notice that we don't have the time or space in this training to give full treatment of what an RDBMS is and to really deep dive into the structured query language in particular. I do want you to be aware that I've created not one, not two, but 3 CBT Nugget series on MySQL, and you'd be well advised to take a look at those. Actually, I've done another CBT Nugget series on Microsoft SQL Server 2008. Any of those training products would give you a really nice understanding of what ACID means. It'd get you familiar with the structured query language and the basics of RDBMS design, administration, and development. Anyway, SQLite is a linked ACID-compliant transactional database management system. Linked means it's actually embedded as a library in your application. Now, what are the benefits there? Certainly portability, wherever your application is, your SQLite database is. Another one is speed, tremendous speed, because we don't have any latency introduced with inter-process communications or IPS traffic. In other words, you have your Python program running in one process on the system, and then let's say MySQLD running as another process. There's obviously going to be some latency there with those inter-process communications. Here, your Python application and your SQLite run in the same process, so it's going to be very fast. Now, you can create SQLite databases in memory that you're not saving any data permanently. It's just kind of used for scratch space. Or more commonly, you can manifest your database as a file in the file system. You know, you're probably using SQLite databases every day and you don't even know about it. Mozilla Firefox, Mozilla Thunderbird, the Adobe Air desktop application environment, Palm's WebOS, the iPhone OS, the list goes on and on. SQLite is pretty ubiquitous nowadays, and you can download and install a distribution of SQLite for any operating system, and there's tons of management add-ons for this free and open source product. Wikipedia has a good article on D. Richard Hipp. He's the computer scientist who is the primary author of SQLite. And by the way, he does pronounce this product SQLite and not SQLite, as some folks pronounce it. The homepage for SQLite is sqlite.org. Very simple, elegant page. However, for our purposes in Python, we actually do not need to worry. I repeat, we do not need to worry about downloading and installing SQLite. The reason for that is that recent versions of Python, certainly 3 included, bundles SQLite with the CPython distribution available at python.org. Now, whether other distributions include SQLite, I will defer to those particular project home pages, but CPython does give you SQLite. Now, in the wild and in the literature, you're going to see references to PySQLite and SQLite 3. These are the same thing. They both refer to the SQLite database. PySQLite is the name of the project. that's developed externally of CPython, of course. The module that comes standard with Python 3 is SQLite 3. This is a standard library module. You certainly remember PyDoc, right, from earlier in our lesson. You can look up SQLite here and take a look at the page in a web browser and read all about its included functions. There's connect, we're going to be using that very shortly, and so on. Speaking of connection, using SQLite in Python is remarkably easy, as you're going to see in the upcoming demo. The first object you create is called a connection object. This is a handle to a particular database, and it functions a little bit like the read function does with files, in as much as you use a connection object to open a handle to an existing database, or you can create a new one on the fly. The databases are binary files that exist in your file system. You can give them any extension you want. You can give them no extension. I've seen SDB given. I've seen .db given. It's really administrator preference there. You can also create a connection object using the memory flag, :memory:. This generates a non-persistent in-memory database that's useful for testing. But of course that data is volatile, and after you close your session, all of that goes away. After you have your connection object up and running, the next thing you'll do is create a cursor object. Now this isn't exactly the kind of cursor that you're used to working with, say in MySQL, Oracle, or Microsoft SQL Server. In Python SQLite, a cursor object acts as a handle for particular database objects. So once we're in a database, we can create and edit tables, we can do inserts, updates, deletes. We can certainly run select statements. Speaking of those aforementioned structured query language statements, the execute method is used in conjunction with your cursor object to execute SQL. Now, depending upon your previous experience with RDBMS systems, there's always the question, how faithful is a certain platform to the ANSI ISO SQL92 standard, which is pretty much the benchmark standard. There's been a couple since then, but this is pretty much the benchmark for defining standards compliant SQL. And the bottom line is SQLite is very faithful to SQL92. There are some minor departures, but then again, you know what? Microsoft with its Transact SQL, tons of departures from SQL92. Oracle, MySQL, they all these different platforms have their own implementations of ANSI ISO SQL, so it's really not a big deal. Anything you know about standard SQL data definition language statements like create, alter, and drop, and data manipulation language statements like select, insert, update, and delete will work just fine. So enough of me flapping my gums. Let me show you how this actually works in practice. Alright, in this demonstration we're going to work with database access to SQLite and Python 3. First I'm going to import the necessary modules. Now really we just need the one, the SQLite module, but I'm going to import OS in addition to SQLite 3, and that's simply so we can invoke the get current working directory and verify where we are in the file system on the host computer. The reason for this is very simply that when we open up a connection and create a new database in SQLite, it's going to create that database file in your current working directory. So you'll want to also make use of the change_dir function if you need to flip over to another location in the file system. But for now we're fine in the Python 31 directory. I'm going to create a connection object here by calling the connect method of the SQL3 library. And here's where we specify a path to an existing database, or if we want to create a new one, which we do right now, you can specify that value as a string. Remember, an extension is optional. I'm not going to use an extension for mine because I'm only going to be accessing this database from within Python. This is a binary file, as I've stated before, so you don't want to try cracking it open in Notepad or HexEdit or any tool like that. You might wind up corrupting the database. If we run type on this connection object, tells us that we've created an instance of the class SQLite3.connection and therefore inherited all of the properties, attributes, methods, etc. inherent in that base class. Next thing we want to do is create a cursor, which remember is a handle to that database. So this is going to be a call to the cursor method of our new instance, con.cursor. cursor. At this point, we've created a new database. If I bring up Windows Explorer for just a minute, you'll see we have a file called HRDB. It's empty. It's 0 KB. We haven't added any data to it, of course. We're about ready to do that. Now, I'm skipping over a ton of architectural stuff. What is the purpose of this database? How are we going to create the schemas or tables? And how are we planning on linking those? We can do joins. We can do one-to-many relations, one-to-one to relations. All your traditional relational database stuff is available to us here in SQLite 3 library. So be aware of that. In this one, we're just going to create a simple table, do a couple row inserts, and then I'll show how to run select statements against it. Good and good. Now, to do some actions on our database, what we want to do is use the execute method. Execute is really an all-purpose kitchen sink method that we run as an attribute of our cursor, as you see here. And boy, we can do DDL, create, alter, delete. We can do DML. We can do it all with execute. Tip I'd like to give you is to use the triple quoted string format to give yourself some breathing room. Otherwise, you're going to have to use the escape character to do a multi-line. That's going to really come in handy. Remember, if you just do a single quote or a double quoted string and you're in the interpreter like I am, you're going to have problems with line wrapping and getting a feel for where you are. So a good tip is to do the triple quoted string. That way you can press enter to your heart's content. I capitalize my SQL statements just by habit of convention. You don't have to do that if you don't want to. I'm going to create a table called emp, very basic table to store employee information, space, and then just like in ordinary SQL, after the table name, you then pass in parentheses, your column list and your data types. So we're going to create an ID column, pretty standard for a table. It uses the integer data type and has the primary key constraint attached to it. And if you've built tables in SQL, you should be very familiar with that. We'll also create a column called fn, and we're going to do varchar 20. Varchar is a variable length character string. They tend to conserve disk space more than just a straight text or char type. SQLite supports lots of different data types, including the binary large object, or blob, if you wanted to store binary data like audio, video, image files, etc. Finally, I'm going to do ln for last name, also varchar 20. We need to put an extra paren there to close the column list, triple quote, close the execute method. All the gray tells us that we have a complete statement now, and we get a traceback. One nice thing about working in the interpreter is that we can always come back and repeat the last expression. You see what's happening here. I have an extra parentheses, so what I'm going to do is position my cursor before the next column, backspace up a couple times, and then press enter. Good and good. And you notice that it comes back by telling us we've created a cursor object, and this hexadecimal value you see as feedback in the Python shell is the memory location of that object. Now we have a table that's empty, so we need to add some data to it, don't we? We need to do the insert statement to add that data. As I told you, execute is our catch-all bucket for issuing SQL against a database and table. I'm going to triple quote string insert into emp values, open paren, and I'm going to carry this over to the next line so you can see what I'm typing. Triple quoted string allows us to do this. And then in parentheses, we're going to need to fill out data for all three of those columns, just like this. Now, are nulls supported? Yes. You can override that with the not null keyword. Could we also populate a row partially? Yes, just standard SQL, insert into emp, and then in parentheses the column or columns that you want to update, and then values, you do that. If you're doing the syntax I am, insert into emp values, that's going to require that we put something for all three columns in the emp table. Let me finish that triple quoted string. I'll tell you, friends, and you're going to see this for yourself once you start coding with SQLite, the biggest pain in the hindquarters here is not the syntax. As you see, the syntax is elegant and straightforward. The toughest part is just figuring out and remembering how many parentheses you've opened and making sure you close them at the correct spot. You can see here I've spent some time in the background with some tracebacks that are nothing else than syntax errors. Ay, ay, ay. Well, I'm glad I can, once I've finally put a row into this table, I can put my cursor back on it, hit enter to get it back, and then simply backspace to change my data. this point I've put in 2 rows into that emp table. Final thing we want to do is run some SQL. We're going to run 2 select statements to retrieve data. The first one is your traditional select splat or select star that retrieves all columns, all rows from that table. Once again, cur.execute, and then as a quoted string we use our SQL select star from emp. Actually, I might want to issue a commit, and the commit is a method not of the cursor, but of the database object. Locking in SQLite isn't as fine-tuned as you'll find in, say, Microsoft SQL Server that can lock a database at many levels. Here, the database is locked at the database level, and although this is a transaction-safe system, it's essentially in interactive commit mode, where you have to manually issue a commit statement, and that again is the connection object with the commit method in order to flush any changes you've made to disk and make them permanent. If you really want to be safe, you would want to issue a commit statement after each insert. In this case, I've issued one commit that would roll back a whole bunch of stuff at once now if we had an I/O error, for instance. Again, the notion of transactions and committing is beyond our scope, but be aware that commit is an important and required function in order to make your changes persistent in the database table. Now, back to our regularly scheduled programming. Let's go back to our cursor object and execute as a quoted string our select statement, select star from emp. Notice that that just creates another cursor object. We need to print yet another method. There's fetch one and fetch all. Actually, there's fetch all, fetch many, fetch one. If you want all the results of the query to come back, you'll pass in the cursor.fetchAll with open and close parens, no arguments. And you'll notice that the output comes back as a list of tuples. We have 1 row tuple, 2nd row tuple. The last thing we'll do is issue a selective select statement, and what I mean by that is cur.execute. This time we'll select all columns from emp where the ID is equal to 1, you see. So you can just structure your SQL. You can use your sorts, your ascending and descending sort keywords. You can use your booleans and or not. All of that standard stuff is supported just fine. Let me close that string and let me fetch all again. And of course we just get a single row back this time. Final thing we do is formally close the database on the connection object, and that's by issuing con.close. Python and database access. At this point, now that you've reviewed this nugget, I hope that you're as excited as I am about how easy it is to link your Python project to one or more relational database management systems. You now should be familiar with what the DB API version 2 is, what APIs are in general, and where you need to go to get a head start on finding the appropriate connector between Python and your RDBMS of choice. Because it's so convenient, and also because it's bundled in the standard library, I showed you specifically how to connect up Python to SQLite. If you weren't really clear on what SQLite was before this nugget, you sure are now, and I hope, again, you're as impressed with this little guy as I am. I hope that this has been informative for you, and I'd like to thank you for viewing.